All right, in this video, I'm going to give a hint for problems in homework set 4.3 to 4.4. So, as I did before, let's begin with problem number 17, the last odd number question. Okay, I'll do a backward. So, problem number 17, number 15, sorry. So, here, winning the jackpot is in a particular lottery requires that you select the correct five numbers between 1 and 45. And then you separate drawing. You must also select the correct single number between 1 and 27 to find the probability of winning the jackpot. Okay, so so first we need to figure out the number of cases, number of outcomes. Okay, I mean number of way to select the six numbers between 1 and 45. Okay, so here then we need to the figure out whether or not the order is matter or not. Okay, order matters or not. Okay, so in when you do when you select the sixth number in a lottery, the order matter? No, right? So order doesn't matter. So and then can we then select the same number? I mean, same number twice, multiple times? No, in a rotary, in a common sense, right? You just use we just normally I mean we just choose the six different numbers between 1 and 45, right? So order doesn't matter. The replacement is not allowed. So what? That's gonna be combination. Okay. So the 45C 6. Okay, that's the total number of it. Okay. A separate in a separate drawing, and then you must select the so we select the single number between 1 and 27, right? That's also what 7C1, right? Or we can say that. Okay. So but actually 27C1 is nothing but just 27, right? How many ways to select the one single number between 1 and 27? Just 27, right? So there are 27 ways to select the one single number between 1 and 27, right? Okay, so then now let's figure out the answer for the question in the sketch paper. All right, so in these problems, the first one, we need to figure out what 20, I mean not 20, 45. Okay, problem number 15. Okay, 45C 6. Okay, times and then 27. Okay, so that's the total number of way to choose the six numbers and one single number, right? Okay, so give me a second. And then yeah, definitely you can use the formula for the combination, which is the give me a second. The n factorial, I mean right there, NCR is equal to n factorial over n minus r factorial times r factorial. And it's complicated, right? But let me apply it. So here n factorial is going to be 45 factorial, and then n minus r is 39 factorial, right? Times r factorial 6 factorial times 27. Okay. So what does that mean? This one, the that's nothing but I mean this is nothing but 45 times 44 times through the oops 40 factorial 40, and then divide by 6 factorial times 27. Okay, okay. But so if you don't understand, that's totally fine. Okay, you can figure out that combination using calculator. I'll show you how to figure out the combination using calculator. So I use a TI-84. Okay, you go to the math right there. Okay, so press math, and then we go to the probability tab, and there you see the NCR and NPR. NPR is a permutation. NCR is combination. Okay, so first we enter the 45 and okay number n. Okay, and then path math, and then probability. Under the probability tab, we choose NCR, and then we type R, which is 6 in this problem, okay, which is this number, and the times 27. Okay, that's going to be, yeah, we got that number. It's huge, right? So what's the probability? But this, lottery, in the lottery, there is only one jackpot, winning ticket for jackpot, right? Jackpot ticket. So the probably going to be 1 over that number. Okay. By the way, so the problem says that winning, I mean the lottery, we choose 5 number, right? Not 6. It's typo. Okay. So this should be not 39 factorial. It should be 40, and this should be 5. Okay, factorial. Okay. So we got through the 39, and this is 5. Okay. So I made a mistake. I'm sorry about that. Let's see problem number 13. A presidential candidate plans to begin her campaign by visiting the capitals in of 48 states. What is the probability that she selects the route of 4 specific capitals? Okay, so okay, so problem asks you to figure out the probability that she selects route for specific capital. Then we need to figure out total number of outcomes. I mean, total number of way to choose for specific capital out of 48 the state, right? So the okay, so then what? When you think about when you want to figure out to figure number of way to choose the part of you know something out of total, then you need to figure out, is that problem about permutation, combination, or just I mean in the replacement allowed, not allowed, right? Okay, so now then first one, replacement allowed, no, it's not. Replacement is not allowed, right? It's not that kind of problem. And then order matters, yes, order matters. So which state visit first, that matter, right? So the we have to apply permutation. Okay, so then we need to figure out 48p4. Okay, so we need to figure out total number of permutation. Okay, to choose 4 out of 48 capitals, right? So 48p4. Okay, so and then what probability that she selected the root of 4 specific capital is going to be, oh, let me just do that in sketch paper. On number 13, so we need to figure out 48 p4. Okay, so that's going to be what, n factorial divided by n minus r factorial. Okay, so now you know what, that's the what actually that fraction belong to that fraction, right? So this is actually, we can say that one is equal to um yeah, n p r over r factorial. Okay, so ncr can be expressed as np over r factorial. I know this is complicated. Yeah, yeah, it's totally fine. You don't have to fully understand. Okay, because there is a much easier way to figure out 48p4. That means the permutation, number of permutations to choose 4 out of 48. Okay, so that's using we're going to use calculator. So I already did that, 48 NPR4. Okay, so I got that number. So then what's the probability that she select the root of 4 root of 4 specific capital? 1 over that number. Okay, that's going to be answer. All right, let's see next problem. Problem number 11. If you know the names of the remaining 4 students in the spelling bee, what is the probability of randomly selecting an order and getting the order that is used in the spelling bee? So to figure out the probability, we need to figure out total number of way to list 4 students' name. Okay, let's say, and for convenience, let's say the 4 students' names is A, B, C, D. Okay, then we need to figure out total number of way to list 4 names. Okay, A, B, C, D, or C, D, B, A, or D, C, B, A, something like that. Okay. Then you hear order matter. Yes, order matter, right? So that's going to be permutation problem. So the 4 P4, which is a 4 factorial. Okay. So keep in mind this, if you want to figure out total number way to list or arrange an object or something, or the seasons, whatever, the arrange seasons or some object, the n, let's say n object out of n object, that's gonna be n factorial. Okay. So what's a factorial? So the factorial means n factorial is what? This is going to be n times n minus 1 times through the 1. Okay, just the multiplication of numbers starting from n and decreasing by 1 until we get 1. Okay, so the now then in these problems we do 4 factorial, right? So that's total number of way. It means that let's say let me say I mean that's the total number of a way to arrange a list for students name, which 4 factorial. Okay. So, and what's the probability? Selecting the correct spelling bee order 1 over 4 factorial. Okay. And then how can you find out? Is there any way to easier way to figure 4 factorial? Using calculator? Yes, here. So we go to the probability. Okay. First we go to math, and then we go to the probability here, and you see the factorial right there. See the exclamation mark. Okay, that's 4 factorial. So we enter 4. Okay, and then we go to the math, and under PRB tab we choose number 4, the exclamation mark. So we got 24. Okay, so 1 over 24, that's going to be probability. Let's see question number 9. A thief steals an ATM card and must randomly guess the correct 6-digit pin code from a 4-key keypad. So repetition of digit is allowed. It means that replacement allowed. What that means, so we can choose 0. For example, for example, let's say 4-key uh, is 4 keys are just 0, 1, 2, 3. Then you can choose 0 for 6 times. So that's 0, 0, 0, 0, 0, 0. That could be one of the possible outcome, right? So now, then what is the probability of a correct guess on the first try? Okay. So then we need to figure out total number of outcomes. I mean, total number of way to um, choose 6-digit pin code, right? We need to figure out that that's going to be total number of outcomes in the population, right? So so number 9. So then since the replacement allowed, so for example, in the first in that, because we need to figure out the 6. So I just drew the 6 box. Okay, 1, 2, 3, 4, 5, 6. So each box represent the these box represent the 6-digit, okay, pin code. Then the for each box there are 4 possible number, right? Because 4 keypad. So each box could be a 0 or 1 or 2 or 3. So there are 4 possible way to choose a number for each box, or we can say each digit. Okay, and then since also replacement allowed, that's what we can say that. Then we multiply them. That's going to be total number of way to way to choose the 6-digit pin code. Okay, which is 4 to the 6th power. Okay. Okay. When it should have only one what the outcome, which is exactly same number as a 6-digit pin code, right? So the probably going to be 1 over 4 to the 6th power. All right, see problem number 7. Okay, so that's going to be last problem in this lecture video. So in a horse racing, trifecta is bet that the first 3 finishers in the race are selected, and they are selected in the correct order. So those are trifecta involved in combinations or permutations. Explain. Okay, first 3 finishers. Okay, so then it means that there is a ranking, right? Rank first, second, third. So order matters, right? So the since order matters, trifecta involve permutation. So the answer is B. Okay. So the I covered the some most of other problems in the homework set 4.3, 4.4. I hope that video help you to prepare for the test one. Okay, let me stop here.